Welcome to Algeomalist Prep Academy. Today's lesson is evaluating the integral using trig identities.
For the first problem, we are going to evaluate the integral 5 tangent squared of x plus 5 dx. Notice that you can factor out a 5 in the problem. So for the first step, we are going to factor out a 5 and place the 5 on the right side of the integral. We are going to use the trig identity tangent squared of x plus 1 equals secant squared of x to simplify the integral to secant squared of x. From this we get 5, the integral of secant squared of x dx. Now we can integrate secant squared of x dx to get our answer 5 tangent of x plus c.
For our next problem, we will be evaluating the integral of sine x over 1 minus cosine squared x dx. First, we will be applying the trig identity sine squared x plus cosine squared x equals 1. To make this work for our problem, we will subtract sine x on both sides, leaving us with cosine squared x equals 1 minus sine squared x. Now we will substitute 1 minus sine squared x for cosine squared x in the denominator. Now we will distribute the negative. We are left with the integral of sine x over 1 minus 1 plus sine squared x dx. Simplified, this becomes the integral of sine x over sine squared x dx. We will then separate the denominator into sine x times sine x. When we cancel out the sine x on top with one of the sine x on the bottom, we are left with the integral of 1 over sine x dx. We will now bring sine x to the top, making it the integral of cosecant x dx. The integral of cosecant x dx is negative ln absolute value cosecant x plus cotangent x plus c. The antiderivative of sine x over 1 minus cosine squared x dx equals negative ln absolute value of cosecant x plus cotangent x plus c.
For our next problem, we will be evaluating the integral 2x cosine x squared over sine x squared dx. Before evaluating, we must use u substitution in order to eliminate the x squared in the trig function. We will let u equal x squared and then take the derivative of u. Du equals 2x dx. We now rewrite the integral in terms of u. 2x dx becomes du and x squared becomes u. We can now simplify the integral using the trig identity cosine x over sine x equals cotangent x. Finally, we can evaluate the integral. When you integrate cotangent u, you get ln of the absolute value of sine u. Now you can plug back in x squared for u for your final answer.
Thanks for watching. Don't forget to like and subscribe.